A country that supposedly can't innovate filed more patents than anyone else. A country described as facing economic collapse launched more rockets than any nation on Earth. A country that many headlines still portray as merely the world's factory graduated several times more engineers than the United States. Meanwhile, Washington spent another year announcing investigations, restrictions, export controls, anti-subsidy probes, and strategic reviews. Those are all real events. They simply don't point in the same direction. That's worth examining carefully, because this isn't about cheering for China or dismissing America. National power isn't measured by speeches. It's measured by the ability to repeatedly transform knowledge into physical capability. Ships, satellites, factories, power plants, semiconductor fabs, machine tools, and people trained to build them. Everything else eventually follows. Consider one number. China produced well over 5 million STEM graduates in recent years, according to analyses using Chinese education statistics. The United States produces only a fraction of that annually. Raw numbers don't automatically equal quality, and critics rightly point out that American universities still dominate global research rankings. That's true. But industrial systems don't operate on rankings. They operate on scale. If you're building high-speed rail, commercial shipyards, nuclear reactors, electric vehicles, batteries, AI data centers, and an expanding space program simultaneously, eventually the sheer volume of engineers begins to matter. Not because every graduate is exceptional, but because large engineering workforces solve thousands of practical problems every single day. That accumulation is difficult to notice in real time, until suddenly it isn't. Take shipbuilding. 20 years ago, China's commercial shipyards were still climbing the learning curve. Today, Chinese yards account for well over half of global commercial shipbuilding output by gross tonnage. South Korea and Japan remain formidable competitors, but the center of gravity has shifted. The interesting part isn't just that China builds more ships. It's that modern shipbuilding quietly pulls together almost every advanced industry imaginable. Precision steelmaking, heavy machinery, robotics, logistics software, marine engines, electronics, specialized chemicals, advanced welding, and increasingly, artificial intelligence. Shipyards are less a manufacturing sector than a compressed representation of an industrial economy. You don't accidentally become dominant there. The same pattern appears in space. For years, Chinese launches were treated almost as routine news briefs. Another Long March rocket, another satellite constellation, another cargo mission to Tiangong. Routine is exactly the point. When launches become boring, it usually means an industrial system has matured. The United States still possesses extraordinary strengths. SpaceX has fundamentally altered launch economics. NASA remains unmatched in deep space science. American venture capital continues producing technologies the rest of the world studies closely. None of that disappears because China had a productive year, but something has changed beneath the surface. Increasingly, America's response to Chinese industrial advances begins with restrictions rather than replication. Export controls on advanced semiconductor equipment, tariffs, entity lists, investment screening, congressional hearings. Some measures may be strategically justified. Advanced lithography, military technologies, and dual-use systems raise legitimate national security concerns. The question is different. Can restrictions substitute for production? History offers very few examples where they have. In fact, restrictions often buy time rather than solve underlying weaknesses. Time only matters if it's used to rebuild capability. Otherwise, it's simply delay. There's another statistic from last year that received remarkably little attention. China became the first country to surpass 4 trillion yuan in annual research and development spending, while continuing to expand manufacturing capacity. At the same time, provincial governments competed to attract advanced manufacturing clusters in semiconductors, aerospace, robotics, and electric vehicles. Notice the pattern. Research isn't being separated from factories, it's being placed beside them. That matters more than many people appreciate. Because inventions become economically meaningful only after they're manufactured efficiently, improved repeatedly, and produced at scale. A patent sitting inside a filing cabinet creates no wealth. A factory does. Of course, patent numbers alone deserve caution. China files many incremental patents, and not every filing represents a breakthrough. American firms continue leading in numerous foundational technologies, particularly advanced semiconductor design, enterprise software, biotechnology, and frontier AI models. That's an important correction. But it doesn't erase the broader trajectory. It sharpens the real question. If one country keeps expanding the number of engineers, factories, industrial robots, commercial ships, and orbital launches every single year, while another increasingly debates how to slow that process through legal, financial, and regulatory tools, which system will possess more productive capacity 10 years from now? We'll test that assumption next, because the answer becomes much less comfortable once we follow the supply chains instead of the headlines. The easiest way to misunderstand China's rise is to imagine it began with smartphones or electric cars. It didn't. It began decades earlier with machine tools. Machine tools rarely make headlines because they aren't consumer products. Nobody queues overnight to buy a 5-axis CNC milling machine. But every advanced product eventually passes through one. Aircraft engines, satellites, semiconductor equipment, naval turbines, industrial robots, they all begin with precision manufacturing. Countries that dominate machine tools quietly influence everyone else's production. China understood that long before most observers noticed. Beginning with the Made in China 2025 strategy announced in 2015, Beijing identified sectors where dependence on foreign suppliers created strategic vulnerability: high-end CNC equipment, industrial robotics, aerospace components, power equipment, advanced rail systems, new energy vehicles, medical devices, semiconductors. Western governments often focused on the document's political messaging. Chinese provincial governments focused on building the factories. Those are not the same thing. Policy documents don't produce industrial power. Local implementation does. Visit cities like Shenzhen, Suzhou, Ningbo, or Hefei, and the pattern becomes visible. Universities feed engineers into nearby manufacturers. Local governments subsidize industrial parks. Banks extend financing. Suppliers cluster within driving distance. Ports connect directly to export markets. The entire ecosystem reduces friction. That may sound mundane. It isn't. Manufacturing success is usually the accumulation of thousands of small efficiencies rather than one revolutionary invention. Consider electric vehicles. 10 years ago, Chinese automakers were largely dismissed outside their domestic market. Today, companies like BYD, SAIC, Geely, and several newer firms compete globally. BYD alone now produces millions of vehicles annually while manufacturing many of its own batteries and electronic components. Tesla deserves enormous credit for accelerating the global EV transition. In many ways, it forced the entire industry to move faster. Yet something interesting happened after Tesla built its gigafactory in Shanghai. China didn't merely assemble Teslas. It absorbed knowledge throughout the surrounding supply chain. Battery suppliers expanded, precision manufacturers upgraded, automation firms improved, logistics networks became more sophisticated. Domestic competitors learned by operating in the same industrial environment. Industrial ecosystems learn collectively. That's harder to sanction than a single company. The semiconductor industry tells an even more complicated story. American restrictions imposed since 2022 were designed to slow China's access to advanced chips and the equipment required to manufacture them. The strategy targeted extreme ultraviolet lithography, advanced GPUs, electronic design automation software, and key manufacturing tools. From Washington's perspective, the logic is straightforward. Artificial intelligence and military capability increasingly depend on advanced semiconductors. Slowing China's progress protects American technological leadership. That's a rational strategic objective. But strategies should be evaluated by outcomes, not intentions. SMIC, despite severe restrictions, continued improving domestic manufacturing processes. Huawei returned with smartphones containing domestically produced advanced processors that many analysts believed would take considerably longer to achieve. No, these chips are not yet equal to Taiwan Semiconductor Manufacturing Company's most advanced production nodes. That's an important distinction. Being behind isn't the same as standing still. Sometimes discussions about technology create the impression that countries either succeed completely or fail completely. Reality is more incremental. If restrictions force engineers to redesign equipment, substitute components, build domestic suppliers, and invest heavily in local research, short-term pressure can eventually produce long-term resilience. Japan experienced something similar in earlier decades. South Korea did as well. Industrial history contains many examples where external pressure accelerated domestic capability rather than permanently suppressing it. That doesn't mean sanctions never work. They certainly can. But they work best when the targeted economy lacks the size or capital to replace missing technologies. China presents a different challenge because it combines an enormous domestic market with extensive manufacturing capacity and significant state financing. Replacing foreign technology becomes expensive, not impossible. Here's where the conversation usually becomes ideological. One side argues China's state-directed model proves governments should actively shape industrial development. The other insists markets ultimately allocate resources more efficiently than planners ever could. Both arguments contain truth. Both also miss something. The United States has never been purely laissez-faire when national priorities were involved. The interstate highway system, the Apollo program, DARPA, the Defense Advanced Research Projects Agency, and more recently the CHIPS and Science Act all represent deliberate government intervention. China simply intervenes on a much larger scale and over longer time horizons. Whether that model remains sustainable is still an open question. Debt levels are rising, demographics are deteriorating, local governments face financial pressure. The property sector has endured a painful correction. These are genuine structural problems, not footnotes. Ignoring them would make this analysis incomplete. But neither should they obscure another reality. A country can struggle in one sector while advancing rapidly in another. Remember the shipyards we discussed earlier? They connect directly to this broader picture. Steel plants feed shipbuilders. Machine tool manufacturers supply both. Engineering universities replenish the workforce. Ports expand export capacity. Rocket programs stimulate materials science. Battery factories improve chemical engineering. Nothing exists in isolation. It's one industrial network reinforcing itself from dozens of directions. And that's where the comparison with the United States becomes less about China and more about what America gradually chose to become after the Cold War ended. The United States made a bet. It wasn't written into law as a single grand strategy. It emerged through thousands of corporate decisions, trade agreements, financial incentives, and political assumptions. The bet was simple. Design would remain in America. Manufacturing could happen somewhere else. For a while, it worked remarkably well. American consumers enjoyed cheaper goods. Corporate profits expanded. Wall Street rewarded companies that became asset-light. Why own factories when suppliers overseas could manufacture more cheaply? Why invest billions in production when software promised higher margins and faster growth? From a shareholder's perspective, the logic was difficult to argue against. From the perspective of long-term national capability, the calculation looks different. Manufacturing isn't just about producing objects. It's where engineering knowledge accumulates. When engineers stand next to production lines, they discover defects, improve processes, redesign components, and shorten development cycles. That knowledge rarely appears in patents or academic papers. It lives inside factories, supplier networks, and experienced workers. Once those ecosystems disappear, rebuilding them becomes far more difficult than closing them. The semiconductor industry illustrates this perfectly. The United States still leads in chip architecture through companies like NVIDIA, AMD, and Qualcomm. American firms dominate electronic design software through companies such as Cadence and Synopsys. Research universities continue producing world-class innovation. Yet the world's most advanced chips are overwhelmingly manufactured elsewhere. That wasn't inevitable. It was a consequence of decades of specialization. The CHIPS and Science Act represents Washington's recognition that market forces alone were no longer preserving critical manufacturing capacity. Tens of billions of dollars are now being directed toward domestic semiconductor production. Notice what that means. The United States is no longer arguing that industrial policy is unnecessary. It's arguing that it waited too long. There's another statistic that rarely receives enough attention. China installs more industrial robots each year than any other country. According to the International Federation of Robotics, Chinese factories account for over half of the world's annual industrial robot installations. That isn't because labor is becoming cheaper. It's because China is preparing for labor to become more expensive. Automation is replacing demographics. Many analysts still describe China as if its competitive advantage rests on inexpensive labor. That description expired years ago. Average manufacturing wages have risen substantially over the past 2 decades. Beijing understands that it cannot compete indefinitely by paying workers less. Its response has been to make workers more productive instead. That distinction matters enormously. Higher productivity supports higher wages without necessarily increasing production costs. Germany demonstrated that decades ago. South Korea followed a similar path. China is attempting to do it on a vastly larger scale. Will it succeed completely? I'm not convinced. The demographic challenge is real. China's working-age population has begun shrinking, and no amount of automation fully replaces declining birth rates. Pension burdens will grow, healthcare costs will increase, economic growth will naturally slow compared with the extraordinary expansion of previous decades. These constraints are significant, but they don't automatically reverse industrial momentum. Here's where my own thinking shifted. For years, I viewed the competition primarily through technology. Who had better chips, better AI models, better software? Increasingly, I think that's backwards. Technology follows production more often than production follows technology. A country that consistently builds more factories, graduates more engineers, deploys more robots, and launches more satellites creates more opportunities for unexpected breakthroughs. Innovation isn't simply the result of brilliant individuals. It's the byproduct of dense industrial ecosystems. That doesn't guarantee leadership. It increases the odds. Remember the patent numbers from the opening? They matter less than many people claim. The more revealing question is this: which country is better at turning ideas into products that millions of people actually use? Because an invention becomes strategically valuable only when it can be manufactured reliably, affordably, and at scale. This is where the conversation reverses. For years, many assumed America's greatest advantage was innovation, while China's strength was execution. Today, those categories are beginning to overlap. China is improving at innovation. America is trying to rebuild execution. Those trends can exist simultaneously. And if they continue for another decade, the global balance won't change because one side suddenly became weak. It will change because one side spent years reinforcing its industrial foundations, while the other gradually remembered why those foundations mattered in the first place. That realization leads to an uncomfortable conclusion. The most consequential competition between Beijing and Washington may not be taking place in the Taiwan Strait, the South China Sea, or even in artificial intelligence. It may already be unfolding inside factories that most people will never see. Factories rarely trend on social media. Container terminals don't dominate television debates. Machine tool exports almost never become campaign slogans. Yet history has an odd habit of rewarding countries that quietly improve these things while everyone else argues about them. That brings us back to the title. China filed more patents, built more ships, graduated more engineers, launched more rockets. America, meanwhile, seemed to spend much of the year announcing another investigation, another tariff proposal, another export restriction, another hearing on strategic competition. The contrast is striking, but it can also be misleading if we're not careful. Restrictions are not evidence of decline. Sometimes they're necessary. The United States has legitimate security concerns about advanced semiconductors, quantum computing, hypersonic systems, biotechnology, and military civil fusion. No serious strategist believes every technology should flow freely between geopolitical rivals. That's not really the debate. The debate is whether defensive policy can substitute for offensive capability. History suggests it cannot. The countries that shape the international system usually don't do so by preventing others from building. They do it by building faster themselves. Think about the United States after the Second World War. It didn't become the dominant economic power because Europe and Japan were constrained. It became dominant because American factories produced extraordinary volumes of steel, automobiles, aircraft, chemicals, consumer electronics, agricultural machinery, and eventually computers. American universities attracted talent from around the world. American laboratories commercialized discoveries. American companies scaled them globally. The attraction was productive capacity, not regulation. That's the benchmark Washington should probably measure itself against, not against China, but against its own history. There's another misconception worth clearing up. People often describe this as a race with a finish line. It isn't. Industrial competition resembles physical fitness far more than a sprint. Miss a month at the gym and nothing dramatic happens. Miss 10 years and recovery becomes painfully slow. Manufacturing ecosystems behave the same way. Skills disappear through retirement. Suppliers close. Specialized equipment becomes obsolete. Young engineers choose finance over production because that's where incentives lead them. Eventually, the missing pieces become visible only when you need them. The COVID-19 pandemic exposed that reality more clearly than any government report ever could. Suddenly, countries discovered they couldn't easily produce medical equipment, pharmaceutical ingredients, semiconductor components, or even basic protective gear without relying on long international supply chains. The lesson wasn't that globalization had failed. The lesson was that efficiency and resilience are not identical. Many governments are still adjusting to that realization. My own view is fairly straightforward. I don't think China is destined to overtake the United States in every field. Predictions of inevitable Chinese supremacy are just as simplistic as predictions of inevitable Chinese collapse. Great powers rarely move in straight lines. Economic history is full of unexpected reversals. But I do think we've spent too much time treating industrial output as an old economy statistic while celebrating financial indicators as if they alone measure national strength. They don't. A nation cannot consume its way to technological leadership. It cannot litigate its way to industrial dominance. And it cannot permanently outsource production while expecting to remain the center of production-driven innovation. Those are difficult realities, regardless of which country we're discussing. Here's the question I keep coming back to. Imagine it's 2036. One country has continued expanding engineering education, automated manufacturing, commercial shipbuilding, advanced energy systems, and orbital infrastructure. The other has spent another decade debating how to contain the first country's progress. Which one would you rather bet on? For me, the answer isn't really about China. It's about incentives. Countries become what they reward. Reward engineers and you'll probably get more engineering. Reward manufacturing and factories tend to multiply. Reward productive investment and capital usually follows. Reward paperwork, speculation, and endless procedural battles. Don't be surprised when those become your fastest growing industries. That may be the most important lesson hidden beneath all these statistics. Because headlines disappear within days, industrial capacity compounds for decades. My prediction is this. Over the next 10 years, the defining competition between the United States and China will shift away from tariffs and sanctions toward a race to rebuild productive ecosystems. Washington has already begun that process through semiconductor incentives, infrastructure investment, and reshoring initiatives. Whether those efforts are large enough and sustained long enough is still uncertain. China, meanwhile, will almost certainly encounter slower growth, demographic pressure, and financial strains. But if it continues converting capital into engineers, infrastructure, advanced manufacturing, and scientific capability at anything close to its current pace, those structural headwinds alone are unlikely to stop its industrial ascent. The country that wins the next decade won't necessarily be the one with the loudest rhetoric. It will be the one that quietly makes more things the world cannot afford to live without. If you've been following this series, I'd be interested to know where you think the evidence points. Not where you'd like it to point, but where the data leads. That's usually a more interesting conversation. And history has a dry sense of humor. It rarely asks who gave the better press conference. It usually remembers who built the ship.